Believe it or not, when React first launched, it was not well received. Developers really didn't like it, and at first glance, why would they? It was drastically different than anything that had come before it. So the question is, how in the world did React go from sentiments like this to being universally loved and mostly respected? To answer that, we need to go back to before React was created. At the time, building for the web was different. jQuery, Backbone, and Angular dominated discussion. jQuery was the most popular way to build for the web. It embraced websites for what they truly were, a tree of DOM nodes. With jQuery, the state of your application lived inside the DOM. Whenever you wanted to update that state, you'd imperatively traverse the DOM, find the node you wanted to update, and then update it. jQuery revolutionized building for the web by both creating a simple and unified abstraction over manipulating the DOM that worked in any browser, regardless of typical browser compatibility issues.
It's incredibly aggravating for me to have to deal with all these cross-browser issues all the time.
Sure.
So I was constantly just, I wanted to develop my app in Firefox and to have it just work in Internet Explorer, and
Sure.
it just wasn't possible.
Right.
So there was existing frameworks. Like at the time, there was Prototype and MochiKit, and I think Dojo was starting to come around as well. But none of them, I felt that they didn't have the exact level of dedication towards fixing the bugs that I wanted, and they didn't have the API that I want. I wanted something that was nice and terse and short, that just could let me write and get done.
Ironically, jQuery's biggest blessing was also its biggest curse. Turns out relying on shared mutable state was a bad idea. With jQuery, what started out as a simple way to update DOM state typically devolved into a mess of spaghetti-like mutations that were both hard to predict and keep track of if you weren't careful.
Fine, you're doing splendidly. Speed it up a little!
What jQuery needed was something that encouraged a little bit more structure.
Now it's time for you to jump into more Backbone, you little devils.
Backbone.js invented the model view controller pattern. That's a joke. But it was the first popular JavaScript framework that embraced the traditional software design pattern and brought it to building for the web. In just 2,000 lines of code, Backbone allowed you to decouple your application state from the DOM. Instead of living in the DOM, Backbone state lived inside of its models. From there, whenever a model changed, all the views that cared about that model state would re-render. And that was it. Backbone's entire philosophy was to be as minimal and unopinionated as possible. So much so that the default implementation of Backbone's method responsible for rendering the view was a no-op. That's a fancy way of saying it was entirely up to you to implement your own view and templating strategy. But you know what wasn't minimal and unopinionated?
Anyway, so what is AngularJS? It's what a web browser would have been had it been designed for web applications.
This introduction talk was the perfect representation of the AngularJS project. Not because of what was said, but because Miško did it entirely barefoot. A perfect analogy for the fact that AngularJS did whatever the fuck it wanted. The idea was simple. What if HTML was more powerful? With AngularJS, you got everything you'd ever want, and much more, out of the box. Two-way data binding, data filters, routing, controllers, dependency injection, templates, literally a mini version of jQuery. AngularJS changed the game because it was a true, opinionated, all-in-one framework for building web applications. Now, you need to remember the environment we were in here too. This was 2011. Being a pure front-end developer was much more uncommon than it is today. The highly opinionated nature of AngularJS was convenient for back-end developers who were given the unfortunate task of working on the front end. This wasn't as uncommon as you might expect, and it fueled AngularJS's popularity. The problem, among other things, was that AngularJS loved two-way data binding.
80% of what you do is just DOM manipulation, DOM munging. And 20% of what you're going to do is the actual interesting stuff of what the application does, right? And so we want to get rid of this 80% portion. So how do we do that? Well, as I said, Angular is kind of like a spreadsheet. So if I start typing, notice same exact behavior, it updates immediately, but notice how simple it is.
Two-way data binding was Angular's way of updating the view whenever the model changed, and updating the model whenever the view changed. In theory, this was nice because you didn't have to worry about doing manual DOM manipulation yourself. In practice, well, implicit state changes usually lead to code that is hard to follow and hard to debug. It also led to performance issues since AngularJS had to constantly scan your app looking for state changes. Now, though they were the most popular, building for the web consisted of more than just jQuery, Backbone, and Angular. But regardless, the majority of these post-jQuery frameworks had one thing in common: models. And specifically, models that we kept in sync with the view. But what if you could avoid that problem entirely?
The simplest way conceptually that we've found to build views, to build this piece, is to just basically avoid mutation altogether. What we found is that if you could just anytime your data changes, blow away our view and just re-render the thing from scratch, like that would be so much easier. From a developer standpoint, we want to be able to say, okay, anytime anything changes, we're just going to start over. We're just going to blow everything away and re-render from scratch. But we want to do it in a way that's actually performant and actually provides a good user experience, right? So the solution that we came up with internally is called React. And here is a JavaScript library for building user interfaces.
One of the core innovations of React was that they made the view a function of your application state. All you have to do is worry about how the state in your application changes, and React can handle the rest.
And this is actually really simple because it's so declarative. Every place we display data is guaranteed to be up to date. And we do it without magical data binding, without dirty checking the model, which can be expensive. And of course, this is a modern framework. There's no more explicit DOM operations, and everything is declarative.
But this was really only half the picture. The real innovation happened when you encapsulated this idea into a proper component-based API. By doing so, the same intuition you have about creating and composing together functions can directly apply to creating and composing components. However, instead of composing functions together to get some value, you can compose components together to get some UI. To truly embrace a component-based API, React needed a way to allow you to describe what the UI for a component would look like from inside the component itself. Now, this is where most of the initial hate for React comes from, and it had to do with React's interpretation of the separation of concerns principle. If you're not familiar, separation of concerns is a software design principle for separating a computer program into distinct sections. Historically, the way you adhered to this on the web was to have your HTML separate from your CSS, which was then separate from your JavaScript. But React had a different interpretation. In React's opinion, anything that had to do with rendering the view, whether that be state, UI, and in some cases, even styling, was part of its concern. To accomplish this, React needed a way to allow you to describe what the UI for a component would look like from inside that component itself. Well, describing UI is already a solved problem. That's what HTML is really good at. But you can't mix HTML and JavaScript, right?
If you pay attention to the API, React is a JavaScript-first paradigm. And there's a lot of reasons for that. Because JavaScript is powerful, it's flexible, it's a language you already know. You're able to represent interactions and logic that are just really hard to do in other more constrained languages like templating syntaxes. A lot of other frameworks are kind of letting you define your entire UI in JavaScript alone. But there's one thing about JavaScript that ends up kind of like getting in the way as you build deeply nested components, as you start paying attention to these braces here, and you don't even know which one corresponds to the other one. And so what we did at Facebook is we addressed this problem by inventing a new syntax that's still every bit JavaScript, but it's a little more familiar to somebody that has experience with templates or HTML.
What made JSX different was it combined the power and expressiveness of JavaScript with the readability and accessibility of HTML. If you were already comfortable with both JavaScript and HTML, which you probably were if you were building web apps, then you could get up to speed with JSX in a matter of minutes. Yes, it was weird and different, and most people hated it at first.
I hate it, but I love it.
But once you used it in an actual app, it became clear that React was onto something with their interpretation of the separation of concerns principle. Not only that, but by embracing both JSX and React's component-based API, all of a sudden what used to require imperative operational-like code could be abstracted behind a declarative API. This not only enabled a better developer experience, but also a vibrant ecosystem of third-party components.